Hello, my name's Deborah Crash. I'm a professor at the University of Calgary, and I'm the co-founder and CEO of Path Therapeutics, an early-stage biotech company focused on the development of anti-seizure drugs for the treatment of epilepsy. I'm here today to pitch our NeuroNexus 2020 challenge, which is a machine learning tool for the rapid analysis of video EEG recordings from mice. So our brains have this very natural rhythmic activity that we can easily record by putting electrodes across our skulls. And when you have epilepsy, you can see that the baseline recordings sometimes become disjointed and hyperexcitable with an increase in amplitude. And this is what a seizure looks like on an EEG. We can capture these types of seizures using mice models. So we can put electrodes on mice brains as well. You can see there's a cable here that's capturing the electrical activity, while we also have video cameras that enable us to capture the behaviors of the mice while it's having its seizures. We can then record in real time across multiple days, which we then bring up to the lab where we analyze the EEG recordings for the number of seizures that happen in a 24-hour period, as well as the amplitude and severity of the seizure. It's this step that's a particular bottleneck in our system because 24 hours of recordings can take us up to 8 hours of our time to analyze. And so this is a very slow step in the process. Now, there are other companies that have developed machine learning tools that enable the identification of the most severe seizures, but it does not enable to identify lower amplitude seizures, which are sometimes more informative than the strongest seizures. And so, for example, these machine learning tools can identify baseline recordings, they can identify noise, and then this would be an example of a strong seizure where you have an onset, an offset, and then a middle. And you can see it's a very high frequency, and it looks different than what noise such as licking from their water bottle looks like, or even baseline. So these machine learning tools have helped tremendously, and we're now able to take what would take us 8 hours of analysis down to 10 minutes. But it only captures these types of seizures. And so we're leaving information on the table that I would like you as the NeuroNexus group to help us solve. So for example, here's a low-level seizure. You can see that this would be a baseline. This is quite different than a baseline recording, but it doesn't have the severe amplitude or the onset and duration that you would see in a more severe seizure. So it makes it hard to capture these, especially away from noise. And even more important to us are these interictal spikes. And so these are very low amplitude, high frequency spikes that happen prior to a seizure and are very informative of when a seizure might begin. We are particularly interested in these interictal spikes because these can inform us how our drugs are behaving in an epileptic brain. But to date, there are no tools that capture either these types of low amplitude, high frequency, or even these low level seizures using any of the machine learning tools, and it's too time consuming for us to do this on our own. So we currently do not analyze for these types of data, and it's really unfortunate, and it hinders our ability to understand fully how our drugs are behaving. So your challenge is to develop a machine learning tool that can separate high-frequency seizures from low-frequency seizures, as well as capture these interictal spikes. It'd be ideal if they could be tagged separately, but even if they're just tagged as something to look at, we can then go back and quickly check them, which doesn't take us very long at all. Accuracy is key. If the program misses seizures or if it has too many false negatives, we spend a lot of time validating it, and it doesn't save us much time at the end. An easy-to-use interface would be helpful, but it's not required. It's a tool for us to use, and we're quite savvy in uploading to different interfaces. The necessary skills are to be able to handle a data set with this type of electrical activity. We have hundreds of seizures that are carefully marked that should be available for you to train a machine learning type approach. So the benefits for working on this project, there's potential to patent the software as well as co-ownership. I'm more than happy to have discussions around that. There will be high commercial interest in this type of a tool. As I said, there are various machine learning tools on the market, but none of which work very well. The community, the epileptic community, as well as the ECG community, would be highly interested in using a tool such as this, and there's been expressed a lot of interest. And you get to work alongside us. We're a young biotech. We have attracted investor funds, and so you can be part of this, young entrepreneurial environment while also participating in research that maybe has an industry applicability. So I thank you for listening. I hope you consider our project, and I look forward to getting to work.